Hi again. Today we're going to talk about the conservation of momentum. So to quickly revise, we said that momentum is simply an indication of how hard or easy it is to push an object or change the object's speed or even stop a moving object. So if an object had a high mass and a high velocity, it would have a high momentum and vice versa. Now, in this video, we're going to be talking about conservation of momentum. Now, imagine that two objects collided with each other, okay? There will be three scenarios for the result of this collision. So we have the first object, let's call it M1, and the second object is M2 because each one has a different mass, so they are moving towards each other. They don't have to be moving towards each other, but as an example, they're moving towards each other. Now they collided. What is the result of this collision? Well, we have three scenarios as we mentioned. The first scenario is called the elastic collision. In other words, the objects will just simply bounce off each other and everyone will go in opposite directions. So this is the result of this collision. As you can see, they moved away from each other. Simply, they just moved away from each other. They just bounce off each other. Now, there are two characteristics of elastic collision. In other words, one of the most important things is that before the collision and after the collision, the momentum will be conserved. What does that mean? Let's go back to before the collision. Let's say this object was moving at a velocity, let's call it v1, and this one was moving at a velocity called v2. Now, if I ask you to find the total momentum of these two objects, you're going to tell me simply that the momentum of the first object is equal to m1 multiplied by v1, because we know the equation of momentum p, it's equal to mass multiplied by velocity. So the momentum of the first object will be m1 multiplied by v1, and the momentum of the second object will just simply be m2 multiplied by v2. Now, what we need to know is that this quantity or this amount here before the collision will be the same. In other words, this amount will not change. Let's go back to our equation right here. This is the amount of the momentum before the collision. It's going to be equal to the amount of momentum after the collision. So they collided with each other and they moved back, everyone with a different speed. This had a speed equal to v3 and this had a speed equal to v4. Now, what is the momentum after the collision? You're going to tell me it's m1 multiplied by v3 plus m2 multiplied by v4. What we need to understand is that the momentum before the collision, it's going to be equal to the momentum after the collision, okay? So m1 v1 plus m2 v2, which is the momentum before the collision, or the total momentum before the collision, and after the collision, you can see that they will have the same value because m1 v3, which is the velocity of the object after it bounced off, multiplied or added to the velocity and the mass of the second object. I hope this is clear. Now, another important characteristic is that energy is also conserved. This means that there are no energy losses. Actually, in real life, that's impossible. Two objects colliding with each other, there must be a loss in energy no matter how much elastic they are. For example, let's say two pool balls collided with each other. Well, they will bounce off each other easily, or two marbles, for example. But since we hear the sound of the collision, this means that there must be energy losses. So let's say it's kind of theoretical more than real. So we can say that in an elastic collision, which is theoretical actually, energy is conserved and momentum is conserved, okay? Let's talk about the other scenario. So the first scenario, it's just simple elastic collision, m1 v1 plus m2 v2, it's equal to m1 v3 plus m2 v4, etc. Now, inelastic collision is the other scenario. So in the other scenario, the objects will bounce off each other, but they will go in the same direction. In this case, we call it an inelastic collision. So they bounced off, or they just bounce off each other, but they go in the same direction. Now, they bounced off each other actually after the collision and they went in the same direction, okay? Now, this means that this object will also have a velocity, let's call it v3, and this object will have a velocity, let's call it v4. We can say that momentum is also conserved. So this is the momentum before the collision. We already introduced it. It's up here. This is the momentum before the collision. It's equal to the momentum after the collision. So we can also say that momentum is conserved again, but here there will be some energy losses. Okay, so for example, let's say two cars hit each other. What they didn't bounce off each other. They deformed. They changed their shape. That means there was energy loss. And after they hit each other, they moved in the same direction. So this is an example of an inelastic collision. Mainly, the main difference is that in an elastic collision, we can say that momentum is conserved, and also energy is conserved. But in inelastic collision, we can say that energy is lost due to maybe sound, deformation of the object, etc. Now, the third scenario is called the totally inelastic collision. Well, in this inelastic collision, the objects will just simply stick to each other and go in the same directions. For example, let's say you throw two pieces of dough towards each other. They will stick and become one piece, and they will move in the same direction. Now, in this case, momentum is also conserved, but there's a small difference. Look, this is after the collision. After the collision, look at the direction of the movement. They're moving as if they were one equal mass. Now they are moving as they are one equal mass. So if I want to find the momentum before and the momentum after, the momentum before, it's clear, it's equal to m1 v1 plus m2 v2. But after that, we see that they are moving in the same direction with one velocity. It's like they came or they become one mass. So we can say that the momentum after is simply the mass of the first object plus the mass of the second object multiplied by the velocity of these objects. In this case, momentum is also conserved, but also energy is lost. So as a quick revision, in an elastic collision, we can say that energy is conserved and momentum is conserved. In an inelastic collision, we can say that energy is lost, but momentum is conserved. And this goes also for totally inelastic collision. We can say that energy is lost, but also momentum is conserved. The difference between totally elastic collisions and inelastic collisions is that in a totally inelastic collision, these will become one mass. So we will deal with them as if they were one mass. Okay, this might seem a little bit difficult, but actually it's pretty easy and straightforward. When we solve some problems in the next videos, you will see that the idea is very simple and direct. So stay tuned.